Okay, in this video we'll look at question 10b from the SAM's second paper, the sample assessment papers. Um, this one is probably the toughest differentiation question I think we've seen so far. Um, so we have an object of mass 5 kilograms and it has a velocity described over here. So we've got velocity as a function of time. Um, and again, we know that we're going to need to differentiate this. So even if you're unsure of anything else, this is a really good hint that I've got something in terms of time. Let's differentiate it and get a couple of marks. Um, what else are we looking for here? So we're looking for the instantaneous power. Okay. Um, when t is equal to 5 seconds. So let's have a look at our formula sheet, just to see if there's anything that might be useful for us. So in the formula sheet, this is part of the section from that dynamic parameters and principles. And we want that instantaneous power, and actually that mentions over here, doesn't it? Mechanical power, average and instantaneous. So looking at this equation here, we've got power is equal to force times velocity. So we've actually got something to do with velocity already, haven't we? Um, and we've also got force is equal to ma, mass times acceleration. Now remember from our question, we know what the mass is. I think it was 5 kilograms. What about the acceleration? Well, remember the acceleration is dv over dt, right? It's the differential of velocity. So that's where our differentiation is going to come into it. It's going to allow us to get a. So we want to put these two together. So let's write down those formulas. We've got F is equal to, oh, sorry, not F, oh yeah, no, F is equal to M times A, and power is equal to F times V. So we want to know what the force is going to be at 5 seconds, and also what the velocity is going to be at 5 seconds. So that's why this is a bit tricky, because there's two things that we need to work on at the same time. All right, well, let's first of all do our differential calculus. So let's do our differentiation. So A is equal to dv over dt. So let's differentiate. If I take that first term, 2t squared, and I differentiate it, remember power goes down by 1, we multiply by the old power. That plus 1 is just a constant term, so when we differentiate it, it disappears. So we're left with 4t. Okay. So what is the acceleration when t is equal to 5 seconds? So when t equals 5, acceleration is going to be 4 times 5, which is 20 meters per second squared. So here we've got our A and we've got our M, don't we? Because remember that was 5 kilograms. So at time equals 5, our force is going to be our mass times acceleration, 5 kilograms times 20, giving us 100 newtons, right, as a force. So now we've got our force, we just need the velocity. Again, it's the velocity at 5. Well, we've got an equation for that already. So let's sub in t equals 5 again. So t equals 5, v is equal to 2 times 5 squared plus 1. So 2 times 25 plus 1 becomes 51. So at 5 seconds, our velocity is 51 meters per second. Okay, so let's put these two together. We've now got the force, we've got the velocity. So when t is equal to 5 seconds, our power, remember force times velocity, is going to be 100 newtons multiplied by 51 meters per second, giving us 5,100. This is power, so it'll be 5,100 watts. So our instantaneous power when t is 5 is 5.1 kilowatts or 5,100 watts.